So then the next one, say the student gets 23. So he gets 23 and equals, and so he gets 33%. Okay, so that's just it. So all you have to do is mark equals until your class list is done and you're all finished. Now you can teach this to your fellow teachers. So if they have just a basic calculator, as long as it's a sharp, it will do this. What you do is you say, where am I going to? And then instead of fraction, we use divide by where am I coming from? And then that becomes an equals. Then we say times the first student's mark equals, and then just mark equals. Obviously, with the basic calculator, it will only give you a decimal answer. Okay, so here are all the steps. I will send this presentation to you or make it available for you to download. Don't panic if you can't keep writing all the notes that you want to write. I'll send it to you. So the next thing I want to show you is the mental maths drill function. And I think it's such a great thing to have on a calculator. You know, we always say a calculator is the crutch. So this actually allows your students to practice their mental maths on the calculator. So, sorry, let me do that again. So mode 3 for drill, and then I'll start with math for 0 for math. Okay, so your up and down arrow keys choose how many questions, 25, 50, or 100. Your left and right arrow keys choose the type of question. So plus does 0 to 20 plus 0 to 20, minus will do the opposite of that, times does 0 to 12 times 0 to 12, divide again will do the opposite of those, obviously without dividing by 0 because we have no undefined key on the calculator. And then of course you can do mixed. Now, because we're speaking to senior phase, so we're sort of looking at grade 7 to 9, we expect that students should be able to do plus, minus, times, divide all together. And in fact, it would be really good for them to practice it that way because you don't just get plus questions or minus questions anymore. It now becomes a mixed set of questions. You're looking at BODMAS, you're looking at fractions and all of that sort of stuff. So very good to practice in that regard. However, before you start teaching them factorizing, get them to practice the times and the divide mental maths quite a bit. So leading up in the weeks leading up to teaching factorizing, I would definitely get my students to do the timesing and the dividing on the calculator. Okay. Once you're ready, you press your equals button and the calculator is going to ask you a question. The question is completely random. Okay. So you'll always get a new set of questions and it will always be different for every set that you get. Answer the question, press equals, and you'll get a tick. If you get the answer wrong, it's going to mark it wrong and then repeat the question again. And it's very patient. It will keep asking you that question until you get it right. Now, obviously, if your kid is or your student is guessing, then it's going to take them a long time and they just waste time. So you can actually ask the calculator what the answer is by leaving it blank and just pressing equals. And you'll see now it tells me 9 divided by 9 is 1. So I don't get any marks for that, but I have learned from my mistakes. So that next time I see 9 divided by 9, I know that it is 1. I'm just going to answer a couple more questions so that I don't like complete normal. Okay, and then I'm just going to skip through the rest. So I'm not getting any marks for these that I'm skipping through. Okay, and then here's our last question. So then it says press enter. So we say equals. So I got 6 out of 25 or 24%. Okay, so you can see exactly how well they're doing and how long it takes there. You can time them if you want to, and then you can see the percentage. Now the other mode, the other function in drill mode is actually table, and that is just times tables. And you can select a particular times table. So if you know that you have a student who is really struggling with the 7 times table, you can select, just use your up and down arrow keys to choose. So we're going to choose 7 and then just choose random. Cyril does it in order, so counting in the sevens. Also great practice, especially if they're really struggling. Otherwise, do it randomly. Press your equals button. And again, here, you just have 12 questions and it will just ask you random. Oh, I see I've done this in Cyril. I think I've done it in Cyril. Oh, no, I haven't. It's just, see, but it is completely random. So you'll never get the same sequence of questions, and then they can practice that as well. And again, at the end, you will see your mark out of 12 and your percentage. Okay, so that's just the two different versions of mental maths on the calculator. Cool. Let's talk division with remainders. So we traditionally teach division like so, and let's make it a longer question. So let's say like so. Okay, so we would say 7 goes into 1, 0 times. 7 goes into 15, and then we count in sevens. Sure, I'm really loving sevens today. And then we count in sevens and see, okay, 15 is bigger than 14, but less than 21. So it must be 14, which is 2. So I do so 2 times 7 is 14. And I bring down my 3. Oopsie, sorry, that's a terrible 3. And so on and so forth. Now you can actually do this on the calculator. So if we did it straight on the calculator, let's just press home. Home is just a really nice shortcut. It's a new thing that takes you back to normal mode from wherever you're in. So if you're lost and you don't know where you are on your calculator, just press home. Okay. So from there, let's say we had this question. We could do it in two ways. We could say divided by 7 gives us 218 and 6/7. Okay, or we could do it this way, 1, 5, 3, 2, and then we're going to use our integer divide key and divide by 7, and that will now give us our quotient and our remainder. But if we're doing long division, we can also do it in a step-by-step format. So I'm actually just going to do it on the calculator. Okay, so where's my pen? Say we have 15, 3, 2. And this time we are dividing by 13. That's a terrible example. Let's make this 3, 5, 2. Okay, so we want to know how many times 13 goes into 3,532. Okay, so what we're going to do is I am just going to start with my 13 into 35. And I'm going to use this special integer divide on the calculator, like so. 13. And that gives me an answer of 2 and a remainder of 9. So here I'm going to have an answer of 2 and a remainder of 9. So now I'm looking at 93, right? And so on my calculator, I'm going to say 93 special divide 13 and equals, and that gives me 7 and a remainder of 2. So now I have answer of 7 and a remainder of 2. And then again, we're going to do the same thing. So now it will be 22 special divide by 13 and equals. And now we get an answer of 1 and a remainder of 9. So an answer of 1 and a remainder of 9, because we've run out of things. Unless you were doing decimals, in which case you could continue. But you can see the pattern here is 9292. Although, I mean, we don't know. This would be a 0, so it could be different pattern. So that's just the division, long division, using the calculator to check your quotient and remainder. Okay. So from there, let's look at finding multiples on your calculator. And this is a really nice way to do it. So we're going to use our table mode. We're going to press mode and 2 for table. And let's say, I just want to do a basic one. Let's say we look for multiples of 7. So we're just going to multiply 7 with our x. And to make an x, you just press that button twice. And you say equals. We're going to ignore function 2 for now. Leave our start at 0, our step at 1. And we're going to say equals. And so 7 times 0 is 0. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21, and so on. Now, the nice thing is, because your table is unlimited, they can see all of these multiples, and we can ask them, what is 28 times 7? So we just look up 28 times 7 is 196. Or what is 52 times 7? 52 is 364. And of course, now because we're going into integers with grade 7s, we can also go back up. So even though we started at 0, I shouldn't have picked 52 here. Even though we started at 0, we can go into the negative. So a negative 7 times 1. sorry, positive 7 times negative 1 is negative 7. Positive 7 times negative 2 is negative 14, and so on. And I will discuss this in a little bit more detail just now when we look at teaching integers and the rules. Okay, so I just wanted to check where I'm at. All right, so let's look at fact pairs. Again, we're going to use the table mode. So let's say, for example, we want fact pairs of 36. So we type in 36. This time we press our fraction button and we press RCL twice, and that gives us 36, okay? And then again, we're just going to equals through all of them. We don't need to change anything. Here are, okay, before I continue, anything divided by 0 is undefined, which is where the stripy line comes from. And this stripy line in grade 10 is called asymptote. But before that, we just call it undefined. So it's a good thing, it's a good reminder to remind your students, okay, listen, anything divided by 0 is undefined. You need to make sure that they understand that concept. I often, in my journeys through extra calculator skills with students, find that they don't know what anything divided by 0 is. And so I often tell them the stories of the cupcakes. I won't digress today, but it is a very important thing to know, and it will help if they already understand this now in grade 7, 8, and 9, so that when they get to grade 10, it's not this huge, crazy thing that they're experiencing. Oh, it's just a line that means undefined. Okay, back to the story at hand. Here are your fact pairs. So we've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So we know 5 is not a factor because it has a decimal remainder. So we ignore it. 6 and 6. And then we've got 7 and 5 point whatever. So we can see that the numbers have switched around, and then we know we've got all our factor pairs and we can continue. So that's just finding factor pairs. Now from factor pairs, I actually originally had factorizing later on, but it doesn't make sense because once you know how to find factor pairs, you can factorize. So how I like to teach it is actually to look at the sign at the back first. So if the sign at the back is a plus, I know that the signs in my brackets will be the same, okay? And if my sign at the back is a minus, I know that they are different. Okay, pardon my handwriting with mousing. I am not good at it. Okay, so the next step that we need to do is to look for our factor pairs of 6. Now, when there's a plus at the back, it means the signs in our brackets are the same, and we know which sign to use because it's the one in front of B. So we'll have it like that. So it'll be x plus and x plus. And then we look for factor pairs of 6 that add up, because it's a plus at the back, to 5. So on our calculator, we're just going to go back and we're going to look for factor pairs of 6. So it's just 6 fraction x equals. And here are our factor pairs, 1 and 6 and 2 and 3. And of course 3 and 2. So we're going back again, but let's just start with that. Oh, sorry guys. There we go. Okay, so our factors we said were 1 and 6 and 2 and 3. Sorry, I'm just making x and answer here. Apologies for the shocking writing. Okay, so we said here that this was x plus and this was x plus. Okay, so what we need to do is when the sign at the back is a plus, we add our 2 columns together, and both of these columns get a plus. So 1 plus 6 is 7. That doesn't give us 5, so we move on. 2 plus 3 is 5. So that is our factors, and or what we're looking for. So we write 2 and we write 3. This one, we have a sign at the back, which is a plus, but our sign in front is a minus. So we're going to have 2 minuses. It still means we need to add our 2 factors together to get our middle term. So again, 1 plus 6 is 7. It's not 5, so it's not what we're looking for. 2 plus 3 is 5. So again, we're going to have x minus 2 and x minus 3. Now, the last one we've got is a minus. Okay, so I just want to rewrite this here. So we have x and we have answer. All right, and we have 1 and 6. Ooh. and 2 and 3, right? Okay. Now, because it's a minus at the back, it means my signs in my brackets are different. So I'm not going to fill them in just yet. I'm actually going to use my table to tell me what signs. So I'm going to call this column plus and this column minus, because minus tells me different signs. So one column must be plus and one column must be minus. And now I'm just going to say plus 1 minus 6 gives me minus 5, which is not what I'm looking for. So that's not my set. Plus 2 minus 3 does give me minus 1. So I'm going to put in my brackets plus 2 and minus 3 using the signs from our columns. And then I factorized. And that's pretty much what factorizing comes down to. Are we all happy here? It's making sense. I don't need to do another example. Thanks, Leander. Okay, great. So only Leander's awake. Okay, I'm just kidding. Thanks, Wilson. I appreciate it. Cool. So everyone's happy. I can move on. Fantastic. Let's now look at prime factors. So before I go into calculator side, when we look at prime factors, we can either do the ladder method or the tree method. So let's say we have 16 and we know 2 goes into 16 8 times, and 2 goes into 8 4 times, and 2 goes into 4 twice, and 2 goes into 2 once. And then we have 1, 2, 3, 4. So we have 2 to the power of 4. Now, if we did the tree, we could do the same thing. So we have 16, and 16 is 8 times 2, and 8 is 4 times 2, and 4 is 2 times 2, 1, 2, 3, 4. So we have 2 to the power of 4. Now that's great, and we're going to need this skill in grade 7, 8, and 9. But when they get to grade 10, they need to be able to find those prime factors a lot faster. And when you start solving your exponential equations in grade 9, then you also need to be able to do these quite quickly. So there is a shortcut on the calculator to check that you've got the right prime factors, okay? And that's just as simple as typing in the number, pressing equals, and then saying second function and p factor. And that gives us that one there. And we'll use this function just now again when we teach exponents. And you can put any number you like in here to give you the prime factors of that number. If your number is a prime factor or a prime number, what's going to happen is when, do you see there's a dot there? When you say second function and p fact, you'll see it now changes to just 13 without the dot. So it's showing you that it is just 13 that is a factor. Alrighty. Okay, so moving on from that, we've now added something called highest common factor and lowest common multiple. So say, for example, you have 45 and 20, and you want to find out what the highest common factor of those two values are. So we type in 45, we say second function and number 2. GCD stands for greatest common divisor, which is exactly the same as highest common factor. We type in 20 and equals, and there we go, it's 5. And you can put as many numbers as you like into this string here, and it will still give you answers. So like so. So I've tested it with 64 different numbers on here. I don't think you'll ever need that, but just in case, you know, it's always something that's a good skill to have or to know. And this is particularly nice when they start factorizing brackets and looking for the highest common factor. And you can show them this methodology. You know, we use the whole, so we've got 45 is equal to 5 times 9, and 9 is 3 times 3. So that's 45, right? And then we have 20, which is equal to 5 times 5, right? So our highest common factor we can easily see is just 5 because nothing else is in common. But when you get to bigger numbers, this is obviously a little bit more complicated, and then it's always nice to check your answer. And then if we wanted the LCM, we would line up same. So we have 5. And then we put all the different ones in. So we have 3 times 3 times 5 again. So we have 25 times 9. And then my maths fails me, and I'm just going to check on here. It should be 225, right? Ha, let's see. Ha ha ha. Yes. I'm feeling so smart right now. So that will give us 225. But we can also check that on the calculator. So we can just say we want the LCM of 45 and 20. And there we go. And it will also give us, oh dear, I've done something wrong. That should be a 4. Okay, whoopsie. See, this is why we have calculators to check our answers. So that is going to be 20 times 9, and that will give us 108. And that is exactly why we have calculators to check our answers. Okay, cool. Are we happy with those two functions, so LCM and HCF? Great, okay. So the other thing that's in the first term, and it's more for grade 9s that I think, or grade 8s that we look at exponents. But there's some very nice ways to teach the rules of exponents. So let's say, for example, we have 2 to the 3, and we're multiplying it by 2 to the 4. So we know the rule is when you have exponents with the same base and you multiply, we add the exponents. Sorry, when you have powers with the same base and you multiply, we add the exponents. So that's 128. If I did this and I said 3 plus 4 in my exponents, and just it should give me exactly the same answer. Now, what you can also do is use your p-fact function and look at it like that, which says 2 to the 7. Now, how did we get 7? We can see 3 plus 4 is 7. And if I go look at my previous one, it's also going to show me 2 to the 7. So they can look at exponents and we can teach them the rules that way as well. It's just a really nice, fun way to prove the rules to students. You know, they like having things proved and explored, and anything that's on a gadget is always fun as well. Now, if we want to do squares and cubes and so on and so forth, so here's your square button. So if we want 5 squared, we can just press 5 squared. That's the short way. And if we want something cubed, we can either say second function to the power of 3, or we can say 3 and then use our exponent button and then type in 3 and press equals. And it will give us the same thing. Your square root is here, so it's just type it in and press equals. And of course, if you're working with more than one square root or you have a string of values, just make sure you exit out of your square root by pressing your right arrow key. And then like so. Okay, and then of course your cube root is just second function and their square root button, and that will give us those answers as well. All right. So what I want to show you now is teaching integers, and this is quite a nice thing to do on the table mode. I mean, you've already seen that table can be quite handy. So what we're going to do is we're going to take -1. So just remember to use your negative button and not the minus button, or it's going to give you an error. That's what that previous slide is for. And then, of course, type in your x. Okay. So we've got -1 times any value. That's basically what that stands for. And here we've got -1 times +1 gives me -1. And if we continue down our table, we'll see that a negative times a positive is always a negative. And it doesn't matter how long you go for, that answer will always be a negative, right? And if I go back up my table and I look at my integers on the other side of things, if I have a negative times a negative, it gives me a positive answer. And again, it doesn't matter where you go on the table, you can still see that a -1 times x or -x gives me a positive answer. It's just, again, a nice way to demonstrate the integer rules for students as well. Okay, so from here, we can look at fractions, and we can say, I'm just using my home button to quickly move between our different modes of the calculator. You, of course, will cover this over a number of weeks, but I only have an hour and a bit with you, so I don't want to, you know, take your entire afternoon. So let's say, for example, we want to add 4/5 and 2/9. Okay, so we have 4/5. So that's the first way you can type in a fraction. Or you can press the fraction button first and then type in your numerator, press down and type in your denominator. and there's our answer, 1 and 1 over 45. And again, if we change it, there's our improper fraction, and of course our recurring decimal and our normal regular decimal. So how do you turn this decimal, recurring decimal on? Because we're going to get asked that. What we're going to do is we're going to press down. So sorry, set up first, press your down arrow key and choose 5 for recurring decimal. And then of course it's just as simple as turning it on. And then if we have anything divided like so, it'll again go through. There's your recurring decimal and our full decimal notation, so they can see what a recurring decimal looks like. Okay, you can also type in a recurring decimal. Just make it sure that it goes past that first initial screen, and there you go. So it gives us the same answers. And you can also do patterns. So say, so it doesn't necessarily just have to be a single recurring decimal or a repeated decimal value. So there it is. Okay, we're all still good. You're all still awake. I haven't lost you yet. Thanks, Yanda. Okay, great. So before I do this, I actually just wanted to show you something which is really cool. Thanks, Wilson. Which is factor setup. If we go here to our number 6, it says decimal point, right? If I choose that, I can actually choose what type of decimal point I would like my calculator to display my answers at. So if I wanted a comma, you'll see now when I press change that my answer is now displayed as a comma instead of as a dot. So that's just something. It does come standard as a dot, but you are welcome to change it and make yourself happy doing that on your calculator. Okay. Now, the other thing we often get asked, and particularly when students are working with financial maths and they want to get a decimal answer first, or even if they're just doing decimal calculations in grade 7, what you can do is in your editor, press 2 and choose 0 for right view. Now, line is the old calculator, like the old 531 that we used to have, where your fractions are written in a straight line with your R as the break, okay? So we obviously don't want to do that, but what we can do is instead of having the exact answer, which gives us our surd notation and our fraction notation, we can just choose 1 for approximate. And then if we have a decimal calculation, it will now give us a decimal answer. Again, we can change it so that it goes back to a fraction, but it will first give us the decimal and then the fraction if we ask. I'm just going to change back to exact because otherwise I'm not going to match up with my slides, and that might confuse a little bit. Okay, cool. So let's look at patterns. So in fact, let me just leave it on the slide here. Sorry, I'm having a moment. Okay, so we've got 3 plus 5 is equal to 8. So if our first term is 3 and we're adding 5 every time, we get 8. Then if we just say plus 5, so we don't press anything else, but just plus 5, then what we'll get is answer plus 5. And then we say equals, we'll get 13. And then instead of having to say plus 5 every time, we can just keep pressing the equals button and it will just keep giving us our pattern formula. And we can, of course, do the same thing with the constant ratio. So we can say 3 times 2 is 6. So our first term is 3, and we're multiplying by 2 the entire time. And then we can say times 2 again to get the answer times 2 is 12, and then just equals 24, 48, 96, and so on. Okay. The next thing I wanted to show you is teaching graphs. And this is really a nice way to do it on the calculator. So we're going to go back to our table mode. And I just actually want to see how I've done it. Okay. I am following my logic. Okay. So, you know, when you prepare these things and then you just have a moment. So the first thing that we're going to do is just look at when y is equal to x. Okay. So we're just going to go through those and you'll see whenever x is 1, our answer or our y is 1. So if we plotted that graph, it would just be a 45-degree angle, straight line, right? Okay. But what happens if we change our gradient? So on our calculator, we can put something like 2 in front of the x. And the second, actually, you know what, let me just change it. So let's make our first function x. And in our second function, we'll make it 2x. And we'll look at what happens to the difference, right? So here, when x is 1, our initial function, which is this one, is 1. But our second function is 2. So it's going to be a lot steeper. So what's going to happen is our graph is actually going to, let me just change colors here. Our graph is going to look like that. And if we scroll down the table, that's exactly what we see, right? What happens if we make our graph negative 2x? So let's just go. Now it's switched sides, you see. So when we draw this graph, let's make it blue. It's going to look like that, the mirror image. Sorry, I know I can't draw straight lines. This is where GeoGebra comes in really handy. So you can actually get them spot the points on GeoGebra and join the straight lines and so on. Another really nice way for teaching graphs. And then again, so you can see where I'm heading with it. So they could investigate just gradients and what's happening with the gradients on the calculator. Then, of course, what you could also do is you could have x, and then here we could have x plus 3 and see what happens. So here you'll see that every time our our second function is 3 higher than our original function. So let me just clear these drawings away and put in a new one. So what's going to happen is our original graph is going to look like this. And the second graph is just going to be parallel to it, but raised up by 3. So the entire time, the distance between these two graphs is going to be 3. What happens if we have a negative 3? So what we can do is leave that one there and change this one to a minus sign and have 3. Right? So now the difference of the distance is still 3, but it's in the opposite direction. So we're going to have, sorry, I'm trying to change my colors here. We're going to have a graph over here. So the distance between here will again just be 3, but my point here will be 3. This will be 0, and this will be 3. Obviously, depending on how many graphs they draw altogether on your axis. And you can ask them, okay, so why, what actually happened when we changed the value in front of the x? Well, the steepness of the graph changed, or the slant of the graph changed. So that relates to our gradient. What happens when I changed what I added or subtracted from x? Well, that didn't change the steepness, but it did change the point where the graph went through the y-axis, and it did change where it was drawn. In other words, it moved the graph up or it moved the graph down. And so that's what your plus c value is. And that's just a really nice way to go through your gradients and your graphs with your students. And again, here are all the setups for you as well. Now, I did do a function, but it's exactly the same sort of setup. So you can put in whatever graph you have into the calculator, and then it will give you back your coordinate pair. So if we were looking at your inputs and output values for a function, if my input was 0, my output would be 2. If my input was 1, my output would be 12. So that's just the different things that you can do using your table. All right, let's look at Pythagoras quickly. So, I just want to do a time check and make sure I'm not rushing. Okay, I should. We're nearly towards the end. Okay, so Pythagoras, let's say, for example, you have a triangle and the base, I'm having so much fun drawing, please forgive me. So the base of your triangle is 5 and the height of your triangle is 12. And we want to know what the hypotenuse is. In other words, sorry, well, I know the answer, but what is the side here? So what we can do is on our calculator, we're going to type in our x value first, press our x comma y button, press 12, and then say second function and x. And there we have it. 13 is our hypotenuse. And when they get to grade 10 and they're doing trigonometry, this is the angle that the hypotenuse makes. It's that corner there. But don't worry about it now because we're doing senior phase stuff. So it's not important at the moment. But just an FYI and a heads up, that's what's going to happen after that. All right. Let's talk through simple and compound interest and financial maths. I did see that it came up quite a lot in the requests to work through. So let's say we start with some simple interest. So on the calculator, I'm going to type in the initial value. I'm going to say 1 plus, I'm going to type in 10%. So I'm just going to do like so. And then we know with simple interest, it's multiplied by the number of years. But instead of a year, I'm going to substitute in an X instead. And then if we just go through and look at our table, we can see that every year we're adding an extra 100 Rand. It doesn't change ever. We just keep adding 100 Rand the whole time. Now, let's leave our simple interest formula. And in our function 2, all I'm going to do is I'm going to use the same values, but I'm going to change my formula slightly so that it is a compound interest formula, like so. Okay, and then I'm going to say equals and equals. So in this column is my simple interest, the one where we keep adding 100 Rand. Sorry for that value. And here in my compound interest, you can see after 1 year, they've added exactly the same amount. But after 2 years, we can see that I've actually gained an extra 10 Rand on my compound interest compared to my simple interest. And after 3 years, I've gained an extra 31 Rand. And after 4 years, an extra 64 Rand. So it's quite it builds up slowly, but it becomes quite a substantial difference, because when I ask, when does my money double? Well, for compound interest, it's already doubled after 8 years, but it's going to take another 2 years to double my simple interest investment. And you see here, we've already got an extra nearly 600 Rand compared to my simple interest. So that's just a nice way to show them what the difference between simple and compound interest is. And what's actually happening on the compound interest side of things is that after 1 year, we took 10% of the initial value. But at the second year, we took 10% of year one's value. That's why it keeps changing. And at year 3, we took 10%. So we took 121 and added it to 1,210 and so on. So that's what's happening and why the value changes each time. So it's just a nice way to walk through simple and compound interest. So again, all your steps are here for you. And you can see, I think I used a slightly different percentage value. All right, let's go through stats quickly. And this is just really handy for yourselves. I don't know if I would show the students just yet, but it's nice to know. I'm sorry, I keep rushing through this. Mode, 1 for stats, and then 0 for single data. The rest are not important for senior phase, so don't stress about it. And for your own class marks, this is really nice to know. So let's say, for example, we have 9 students, and I'm just typing in their marks, just very quickly. And so, okay, when you're done typing in the marks, you can just press change. So it's just mark equals until you finished typing it all in. Press change to go to your calculation screen. If you want to go back and check your data and scroll through it, just press your change button again to go back. Let's say, for example, I wasn't supposed to add 12. I was supposed to write 72. So what you do is you highlight the 12, you type in the value that you actually want over it, and you just press equals, and the calculator will substitute it in for you. Okay, when you're done and you're happy with all of your data, you can press change. Then it's very simple. All we're going to do is say alpha, we're going to press 8, and we're going to say 0. You'll see on the 8 it says stat there. And that's it. Your number of observations is 9. Your average, which is your x bar, is 65,89 basically. We use the sigma x as your standard deviation calculation. But again, not important in grade 7 to 9. Your sum of all of your values. So if you have class marks that you're working through or class list, and I remember doing it when I was teaching, which was a long time ago. So I don't know if it's still a thing, but there's that answer for you. And then of course, your minimum mark, your quartile 1, median mark, quartile 3, and your maximum mark, which is 98. So those are just the various screens that you can scroll through, and it's just all there, summarized nicely for you. And that's statistics. Simple as that. So there's another example for you to follow. The last thing that I want to share with you is probability. And this is just really just a fun thing to do with your students. So we're going to press second function and 7 for random, and then you have 4 different options. So 0 random is just random numbers between 0 and 1 to 3 decimal places. Now, if you are teaching rounding off decimals, this is a great place to go for some extra questions. Get your students to set it up. Write down the original random decimal. This is when you would use that approximate setting. And then have them round off the decimals to 1 decimal place or 2 decimal places, whatever you like. Your R dice, I can do it now for you quickly. It's just like having a dice. So it's just going to give you random values between 1 and 6. Really a lot of fun if you want to create tally tables. So if they all have a calculator on their computer at home, they can also generate random dice, and then you can have a poll. Who got 6? Who got 5? Who got 3? Or they can put it into the chat function. You also have a coin, so that does zeros and ones. You just need to tell them 0 is heads and 1 is tails. It's the same probability. And then, of course, our random integer function allows you to choose any 2 numbers. So you can say, for example, you want to generate lottery numbers. So between 1 and 52. So we just use that same button we used in Pythagoras over there, and we type in 52. And before I do this, we did it earlier with the intermediate phase. So let's do it together as well. In the chat function, I would like you to choose your 6 lottery numbers. Don't worry, I won't steal them. And type them into the chat now. So any 6 numbers between 1 and 52. Type them into your chat function now. And let's see if anyone wins the lottery today on our Sharp webinar. Awesome. Let's see who we've got here. All right. Okay, so Yvonne says 16, Sianda says 4. Anyone else want to hazard a lottery number? Oh, okay. Wilson's given us all 6. Well done. Thanks, Wilson. Denisha says 9. Awesome. Okay. So once you're done, and they've typed in, I see one more. 13. Thanks, Tasneem. Once you're done, all you would do is press equals, and our first lottery number is 45. Did anyone get 45? You can just raise your hand if you did. No. Okay. 19. Oh dear. 27. Okay, thanks, Brenda. Anyone else got 27? Okay. 50. Nope. 2. And I think our last one, 12. Oh, Wilson got 2. Okay, awesome. Yay for Wilson. Unfortunately, Wilson, you don't win any money because you only got 1. So I think you have to get at least 2 in the lottery to win money. But there we go. So that's just a nice introduction to playing with probability. And you can ask the students, okay, so why does it take so long for someone to get or to win the lottery? Because your odds are so high. But I mean, picking 6 numbers where your odds of choosing 1 out of 52, I mean, that's quite a low probability as well. So there's some really nice examples of what you can do using your probability, your random function. You can use it to test multiples. So generate numbers between 1 and 100 because they need to know up to 99. And then they can do 5 multiples of that number. So really nice just to keep things random and keep students on their toes.